Hello, some students asked me to explain two questions from tutorial 11, question 2 and question 11. So here is question 2. Right. So here we have a mixing problem, so that there is some kind of tank, or I don't know. So this is going to be my tank, that there is some water in the tank. The amount of water is 1000 liters. 1000 liters, I guess. Yeah. Okay, so initially 100 grams of salt is dissolved, and notice that the objective of the question is to find the amount of salt at any time t, right? So if we um, basically what we have here is that the amount of salt is changing with time, and if we denote it by y of t, then we need to write a differential equation for that, right? So if let's say um, so let y of t be the basically the mass of salt, the mass of salt in gram in the tank measured in grams. Okay, and the question asks us to find an equation for y of t. All right, so what is 100 grams of salt initially? So that's the initial condition. So we're given that y of 0 is 100. All right, so what's going on here? So basically we have the inflow. So whatever goes into the tank is some kind of a brine or whatever. And it runs in at the rate of 10 liters per minute. So 10 liters per minute. And each liter contains 5 gram of dissolved salt, right? So the concentration of salt is 5 grams per liter. Okay. Well, at the same time, the mixture that is in the tank is kept uniform by stirring, and the brine, this mixture runs out at the rate of 10 liters per minute. Well, notice that since the rate in and the rate out is the same, it's 10 liters per minute, so it means that the volume of mixture in the tank is not changing, it remains constant. Okay, so what is the concentration of salt in the outflow? Well, since the mixture is kept uniform by stirring, it means that the concentration of salt is going to be the mass of salt divided by the volume of salt, and the volume is not changing. So the concentration of salt is going to be y over 1000 grams. Y is measured in grams, and 1000 is 1000 liters. All right, so now what is the rate of change of salt? So dy dt basically is a sum of uh, two terms, the inflow and the outflow. Well, it's rather difference, right? So it's inflow minus the outflow. So inflow is what? So in the inflow we have 10 liters per minute times the concentration is 5 grams per liter. And notice that liters are going to cancel out, and we are going to have grams per minute, which makes sense because this is the rate of change. So minus 10 liters per minute times y over 1000 gram per minute. And again, sorry, not minutes. So just liters. Uh, it doesn't make sense. Yeah, sorry. So it's 10 liters per minute. 10 liters per minute, and y is measured in grams, and 1000 is liters. Okay. So same liters cancel out, and we have grams per minute. So it all makes sense. Now let's just do the computation. So 10 times 5 is 50 minus y over 100, I guess, and that's it. So this is the differential equation, dy dt equals 50 minus y over 100, and the initial condition is this, y of 0 is 100. So let's solve the differential equation. Yep. So here is the differential equation and the initial condition. So this is an initial value problem. And this is a linear differential equation, so we can solve it by finding the integrating factor. So notice that it is also at the same time a separable differential equation, but it is always easier to solve it as a linear differential equation rather than as a separable differential equation. It's just that you've got to believe my experience. It's just easier. So finding an integrating factor is going to be just easier. All right, so let me rewrite it a little bit. So let me move this to the left-hand side. So this is going to be like y prime plus y over 100 equals 50. Now the integrating factor I of t is going to be e to the power antiderivative of 1 over 100 t, sorry, dt, so which is just e to the t over 100. So this is the integrating factor. So which means that our differential equation is y times the integrating factor prime equals 50 times the integrating factor. So this thing is going to be just the antiderivative of whatever is on the right hand side, right? So y times e to the integrating factor is going to be the antiderivative. So it's going to be 50 times the antiderivative of e to the t over 100 dt. Okay, the antiderivative of the exponential function is just the exponential function, only we need to divide it by 1 over 100, so it's going to be, guess, 5,000 e to the t over 100, right? So if you differentiate that, then you've got to multiply by 1 over 100, and then you will get 50, which is correct. Okay, correct. So, well, plus constant, of course, plus constant. So which means that y itself is going to be, now we've got to divide by this. So it's going to be 5,000 plus c times e to the minus t over 100. So that's the general solution. And now we've got to use our initial condition, right? So y of 0 is going to be 5,000. So now I'm replacing t with 0 plus c times e to the 0 is just 1. So this is supposed to be 100. So solving for c, I get c is what is 100 minus 5,000, so which is minus 4,900. So substituting this number for c, I will get the answer. So the answer is y equals 5,000 minus 4,900 is the minus t over 100. So that's the answer.